It's gonna look a lot like part one. Part one. We're gonna start by covering a few other functions, like we did yesterday, that are a little bit more involved, and then we'll end by talking about something called nested arrays, which is a little bit more of like a practical application, and you'll see what that is as well. Okay, so one method that one method that we talked about yesterday was slice, and that was basically, or rather, slice basically lets you kind of go into the middle of a function, right, and basically lets you extract, right, copy a part of it. We've also learned things like lets you pull, push, shift, unshift, right, and those basically dealt with moving or adding or removing things from the beginning or the end of the array, right. The one kind of big gap that we still have right now that we haven't talked about with regards to how we use arrays is what if I just want to do them in the middle of the array, right? Like, what if I don't want to start at the beginning? I don't want to start at the end. I don't want to just copy it. I want to change an array starting at any given point. How do I do that? And so that kind of Swiss Army knife function is going to be your splice function. Splice does change the original array, and this is probably the shortest way to just describe it is it's used to add or remove as many elements as you want from anywhere in the array. The caveat there is obviously you have to kind of pick one point to start at, right? So you can't say, I want this function to remove 2 from this point and add 5 at this point. You kind of need to pick one point to either add or remove. But to do the thing I saw earlier, which is to add or remove from 2 different points, you just call the splice function on an array twice, right? So anywho, so splice basically allows you to add or remove elements from the middle of the array. And when we say middle, like could also be the ends too, right? So this could theoretically replace a push or unshift or any of those functions too. Um, so let's talk about kind of how the function is constructed. The first argument in a splice function is an index, which basically tells you where to start, right? So it's very similar to the way that slice works. The second element is gonna, or sorry, the second argument that's being passed into the function is going to tell you how many elements to delete from that index, right? And it includes that index. So in this case, if I have my names, which is 3 presidents, I do names.splice 1 comma 1. It means start at index 1, which is 0, 1. So I start at John, and I delete one element, which is John, right? It's inclusive of where I start. So now when I look at my names function, it's just George and Thomas. Make sense? Um, and then what it returns, right? So right now I kind of told you what this function does, and now the question is, what does it give back, right? Because here all it's doing is it's changing the original names array, but what is it getting back to you? Well, what it's actually getting back to you is going to be this thing called single term precedence, and what it returns is a new array was all the things I've just removed, right? So in that way, it works very similar to pop, except the main difference is pop by definition only removes one element, so it just gives you back the element. Here, you have the option of removing as many elements as you want. So JavaScript gives you back everything you've removed in an array. And that array could have only one thing, or even be an empty array. Those are all totally valid. It's just always going to give you back an array. So you can kind of rest assured that's going to be kind of a condition of using Splice. Yeah.
Why is it that it didn't give you back strings in the array?
Oh, it does. This is just we just didn't print the protocol out. But yes, these are all string values. Okay. Yeah. So I'll tell you. What was your name?
Alex.
Alex, and then Caitlin.
So that's if we know what the array is. So what if it's like one of these problems where we just need to splice from an array that we don't know what the names and stuff are?
What if we need to splice from an array where we don't know what the names of it are?
Yeah, like in our workshop problems, we don't input specific data to be like spliced or anything like that. You know what I'm saying?
Yeah.
So if we had to formulate, like say from our workshop, what would that kind of look like using the splice method?
So this doesn't require you to know anything about the array. If you look at the arguments that we're pulling in so far, right? All we're doing is saying, hey, give me a position to start, and then tell me how many things to take off, right? So you could give me an array of numbers, and that's totally valid, right? Start at the second element, so to speak, and take away one of them, right? I could have an array of strings. I could have an array of objects. I can have an array of anything I want, and Splice is going to work on that because Splice basically requires 2 things, which is just where I start, and so far, how many we take off. And so in this case, it's actually not as critical for you to know kind of every single element in the array, as long as you kind of have a good sense of like, okay, the input array is going to be an array of data that I want to do these things to. So yes, there is a certain element there that I have to kind of, it's almost like a contract. Like I don't need to know what every single thing is, but I need to know that like roughly what I want to do with it. So in that case, like even if you don't know what the array being fed in is, if someone says, hey, I'm gonna give you an array of 20 numbers, you don't need to know what each of those numbers are. But if you know you get an array of 20 numbers, you can actually kind of start operating on it, like with the premise of like, oh yeah, I have 20 numbers. I want to remove this like the first six numbers, right? So this is where I start.
I think her question, based on the kinds of problems that we've been getting, is can we use dot splice for things like remove all of the even numbers from the array? Or would we need to use a different method for that, right? Are those the kinds of questions that you're thinking about, like when we're looking for elements with particular characteristics?
Kind of, like I just wanted to know if I put let names equal array, and then let new array equal array dot splice, my begin point and how many I want to remove. Would that be something valid?
Sorry, 1 second. Let me okay. So say it one more time, and I'll just type it out, and then we'll look at it together.
If I put if I created the array like.
Okay, so I've let AR equals, and I'll say I have an array of 1, 2, 3.
Sure.
Cool.
And then I put let new R.
Yep.
Equal R dot splice.
Mm-hmm.
And then parentheses 1, 5.
1, 5. Okay,
Yeah.
cool.
Would that be something that would be valid?
Why would it not be valid?
Because, like, if we had only put 3 input values into the input.
Mm-hmm. Yeah. So let's see, okay. Right, so I guess the main question here is like, hey, like here we're trying to do something that kind of violates, I guess, like I don't know how many things are in my array, so I try to take away 5 elements. What if I'm trying to take away things that don't exist?
Mm-hmm.
Right. Yeah. So I mean, clearly, like just from like me doing it, you'll see that the answer is like yes. Like JavaScript kind of gets to the end of the array and says, oh well, I know you asked me to take away 5. You only have 2 things. I'm just going to take away whatever I could and give it back to you. So in this case, it doesn't throw an error. For a lot of these kind of problems, or a lot of these scenarios in which like things like this are actually like super common. And by this I mean like you're wondering like, okay, in this very kind of when you want to use a function this way, if this number is more, if this number is 0, if this number is like 1 or 2, what happens to it, right? And once again, it kind of comes back to the idea like the easiest way to do this is like do it and try it out, and you'll see right away kind of what the answer is. Like if you ask me organically what this would have given back, I probably would have guessed this, but I also wouldn't be 100% sure, right? If I was writing a function and someone's like, oh hey, like what if you violate like the end of your what if you try to take away more things than that exist in your actual array? I'll just say, all right, let me try it out. Like I'll do this quick stupid example, and I'll know right away. Oh great, JavaScript kind of built to handle this. So once again, right, it's a great question. It's not one that necessarily is like you should memorize. It's more something that you should feel very comfortable testing on the fly if you have to. Cool.
Gotcha.
Yeah. All right. So yeah. So back to Splice. Okay. So far for Splice, I really hope we're recording the sound on this lecture. By the way, I can't really see it once QuickTime starts recording, but yeah. Okay. So Splice. So we talked about how so far we've seen its ability to remove elements and then give it back to you. But we obviously haven't done the other side of what I told you to do, which is how does it add elements to it. And so so this is also still removing elements. But if I wanted to add new elements into the array, I basically just keep feeding it arguments, more and more arguments more and more arguments into the function. So in this case, if I have a function if I have an array of the original members of the Beatles, right? It has 4 names in it, and I do names.splice. The first argument, once again, is just where I start, which is 0, which is 2, so the third element. And what I'm saying is, hey, let's take away 1 element starting at the third element. So I take away the third element. And then while I'm still at this point between the second and third element, I then insert whatever my third argument is. In this case, my third argument is Ringo. So now my function basically says, all right, go through this array, go to Pete, delete Pete, insert wrinkle there, and return an array with one thing, which is Pete. And once again, these are all strings. We just didn't put the quotes there, but that's what these are, right? And the really cool thing here is, if I want to add 2 things or 3 things or 20 things, I can just keep adding them into the function, right? And so this is probably the first time in which you've seen a function that doesn't have like a hard cap on the number of arguments it can have. And in this case, the way that Splice is built is saying it's like, hey, look, and so this is kind of part of your contract, I guess, with using Splice, right? That Splice says, okay, I know the first thing you give me is always going to be a number. The second thing you give me is always going to be a number. Everything else you give me are just things that I'm going to add to the end of, or I'm going to add into the array, regardless of where it is. And so you'll kind of get a better sense for how this works because, like yesterday's workshop, you're going to be building your own version of Splice. But this is just to let you know that a lot of times functions in JavaScript are also very dynamic, right? It doesn't say I only take 3 things. In this case says I take 3 types of things, but that third type it could be as many arguments as you want it to be. Yes.
It's just specific for the primitive types, or you can add objects like another function.
You can have anything inside of here.
Everything, right?
Yeah, because an array can hold any data type. So therefore, if you want to add things in, you can add in any data you want. And sorry, what was your name?
Tom.
Tom. Okay, great. So yeah. So this is basically Splice in a nutshell, right? It can take as many arguments as you want, but the minimum is you need to give it a place to start, how many things to take away, and even if I only want to add in things, I still need to say, hey, take away 0 things, right? Because once again, by using Splice, I'm agreeing to this contract where the second thing I give it is going to be the number of things to take away, right? So even if the number is 0, I need to tell it, hey, it's 0. And then third, fourth, X, whatever, from here on out, everything else is just going to be adding things to the array at the position which I have started at. And and then lastly, obviously, I return all the things I've deleted over the course of this Splice function. In this case, I've deleted 0 things. So what do I return from this function? I return an empty array, an array with 0 elements. Alex?
I think you might have said this, but I just want to double check. So you can't choose 2 different locations in one single Splice function.
This index has to be you can only pick one index. If you want to do this in 2 different places, you got to call Splice one time and then call Splice again after that.
If you did that, do you have to keep track of mathematically? Like, say you started to 0 and you added 3 things, then you would start again at 5.
Yep.
Okay.
Yeah. I mean, yeah. So that's kind of on you, the human, to know that like once you change an array, if you want to use it later, you need to be aware of the changes that you've made. Yeah. Cool. Any other questions?
If
Yeah,
you
Tom?
change the methods,
Yeah.
which method would run first? They left, right, or right, left?
JavaScript executes all functions left to right.
Okay.
So if I want to insert one thing here and do another splice afterwards, it executes left to right, right? So
okay.
Chain function calls executes left to right. In this case, so like when I look at line 5, for example, right, this whole line is not a chain function call. This whole line is actually like the highest level of division we look at it's an assignment, right? I'm creating this variable called remove elements. I'm setting it equal to this. So in this case, when JavaScript looks at this line of code, the first thing that it will actually try to do is it will evaluate everything to the right-hand side of the equal sign first, right? So it does the right-hand side first, like all of this. But then when it tries to figure this out, now we're looking at what are chain functions. It executes this from left to right. So it'll do names, great, names.splice this. And if I have like a .slice here or .splice or something else after it, it will.
What I'm saying is that you can access the Pete index from the second method, right? If you want to remove it for some reason.
Right.
You add it and you remove it.
Right. Method chaining is kind of like it's more of a shorthand. Like it just makes you type less. I don't ever have to chain a function. I just write it on subsequent lines, like one line at a time. And in that case, like the functionality is the same, right? Like if I've changed something in the first line, I should be able to use it in the second line, assuming I did it correctly the first line. Cool. All right, so that's Splice. And once again, right, like you'll build this yourself in the workshop, so we don't need to talk too long about it. You'll definitely get a sense of kind of like the nuances a bit more when you do it. Join is another one that that's fairly commonly used. What join does is join takes all the elements in an array, and it basically turns it into one massive string, right? So if I have an array of 10 names on there, it will literally take all 10 names and shove it for me into one string. So if I have something like Paul, George, John, Ringo, and if I do names.join, I get this thing, Paul, George, John, and Ringo. What the join function really does is really useful. Is usually people use it as kind of like a final step. Say, hey, I have an array of these different things. If I want to kind of put it in like a nice user-friendly manner, I then use the join function, and it outputs into one list string. The join function by default takes no arguments, and so what it does is it will just join everything as a string and separate by a comma. But if I pass it in any arguments, or rather I pass it in a string, really, what it'll do is it will actually say, great, that's what I want my separator to be, right? So by default, when you pass no arguments in, by default, join says, oh, you want your separator to be a comma. If you don't want it to be a comma, then you got to pass in kind of your explicit separator. In this case, it's space and space. So now when I print out my join string, I get Paul and George and Ringo and John. Right? So join is just a way to convert something from an array into a string. And notice how it's concat, right? It's not math. So if I have an array of 1, 2, 3, I'm not doing like 1 plus 2 plus 3 as numbers. I'm doing 1 concatenated with 2 concatenated with 3. So my end result is going to be a string with 3 characters, 1, 2, 3. Right. So just keep it in the back of your mind here. Like you might think of it as like an addition, but it's not addition. It's concatenation. Even when we're dealing with things that use addition like numbers, we convert to a string first, and then we do our kind of plus or our concat operator. The output of join will always be a string. There's no way around that. And then if you want to play around with it and join like nulls or objects or whatever, feel free to play around with it. Like you'll kind of see how all those things shake out too. Yeah, there's just a lot of combinations there, so I'd rather you figure it out yourself in terms of kind of how it looks, right? But yeah, usually it's just a way to kind of join a lot of strings or an array of strings into a single string. Okay, the last one is a little bit more directly named. It's called the concat function. The concat function basically lets you kind of combine 2 strings together, right? The way that we talked about it before earlier is like it would basically just take 2 arrays and we shove them together into one longer array. The array that gets the way, if you notice how we call the concat function, we do array.concat and we pass it in another array. The array that's being passed in gets shoved onto the end of the first array. So in this case, our new array comes back as Ringo, John, Paul, and George. And not most importantly, but like one important thing to note is that when we do this, this gives back a brand new array. Neither older nor younger is ever changing, right? Everything we're doing here, we're doing purely in the confines of this brand new array that we're just creating and returning, right? So this does not modify the original array in any way. Cool. And once again, this is something that I've seen a lot of people make a mistake on. This gives back a new array. If I call this function and I don't have equal signs before it, I might as well not call it, right? Because I'm basically saying, hey, what's your answer? And then not really like accepting the answer, just walking away, right? So whatever this gives back, I need to be able to capture. I need to make sure I'm capturing it in a new variable. If I'm not, that answer is basically going into the void. It's being neglected or just not used anywhere or not stored anywhere. Cool. All right. So that's pretty much it for like the array function that we're gonna talk about. Once again, there's a ton more, and it doesn't really help us to memorize all of them in sequence. But the ones we're teaching you do illustrate not just basic array uses, but also some key JavaScript concepts too. So let's talk about the second thing for today's lecture, which is nested arrays. Nested arrays are important because they actually kind of gives us a little bit more insight into so far we've learned some very, very basic building blocks, right? Like numbers, strings, booleans, and now arrays. But nested arrays kind of shows us one way we can kind of start using those building blocks to create something actually that's quite complex, or at least a bit more complex than kind of the more foundational things that we've seen so far. So as Sam probably mentioned yesterday, arrays can contain any type of value you want, right? It can hold booleans, numbers, strings, but also objects, functions, or in this case, it can also hold other arrays. And so when we say nested arrays, it just means, hey, it's an array in which at least one of its elements is another array. And so when I look at something called when I look at line 3 there, and I look at this function or sorry this array called related things, how many elements is in the array related things? I mean, the answer is right there, all line 7, but the answer is 2, right? Because when JavaScript looks at this, it doesn't care how many things are each inner array. It sees this array as one element, right? And it sees this array as the second element. And I mean, if you look at the comma, there's only one comma in there, right? So therefore, and as far as JavaScript is concerned, is hey, my outer array is still just 2 things. Now, if I look at each element and I know it's an array, then I can count how many things are inside that array. But just know that when we talk about nested arrays here, the count only happens, quote unquote, at the highest level, right? So even though there's, quote unquote, like 4 things here, theoretically speaking, like this to the outer array, this is one thing, and then this is one thing. So therefore, there are 2 things. There are 2 elements in the outer array. Why nested arrays are actually like really critical now is because one of the ways that JavaScript makes it really powerful for us to kind of store information is not just shoving it in a place, but also having ways to quickly access it, right? Like I could take all the books in the world, like throw them in pile in the middle of like a big pit, right? It wouldn't be very helpful because no one ever would access it very, very cleanly, right? But if I put it in a library with a Dewey Decimal System or some kind of categorization, I can now go through and access things really quickly, and now that information is a lot more useful. Same here. In the context of a nested array, we talked yesterday about how when we access element in an array, we use something called bracket notation. So it's, we have an array, we have a bracket, we pass in a number, which is the index, saying, hey, go fetch that. But if this thing is an array, well, now we're kind of getting back to what Tom was kind of hinting at earlier, which is idea like, well, can we just chain together functions, right? Like if I know JavaScript executes from left to right, if I know the first thing's gonna give me this and the second thing's gonna give me this, well, why can't I just like kind of run those together in one line, right? I could definitely do this on each individual line, right? Like let x equals related things index 0, and then let y equals x index 0 too. So let x equals let y equals x index 0 as well. But if I know that hey, if JavaScript is going to evaluate this from left to right, then I can just do related thing index 1, which is what? This second element here, which is an array. And if I put a 0 after that, then I'm basically saying, hey, x, give me the first element, the zeroth index of whatever this was. Well, if this was an array, then the 0th index is just New York, right? So it's kind of a bit verbose explanation, but all of this is to say that when we have nested arrays, we can actually access it the same way that we would any normal arrays, and we kind of chain it together in a way that makes it kind of very clear. That makes it very clear kind of how we got there, right? So if I look at line 6 here, how I got there is really easy, right? How I got to New York is I went to the related things array, I took the second element from that array, and I took the first element from that array, right? Related things 1, 0, right? I now have a very, very clear path of how I got from this entire outer array to just this New York string. And I can do this for any element that I want inside this array because, once again, the whole point of an array is everything can be accessible almost immediately if you know the position or the order in which it's in. Where this gets a little bit more tricky is when we actually start using it. So nested arrays, nested arrays are really good because it can store multiple levels of information, right? But obviously, as you can imagine, if I want to go through every single element in the array, it becomes a little bit more problematic too, right? Because normally, how do I iterate through an array? Well, I use my trusty for, right? I know, the array has a certain length. It goes from 0 to the length, and it's got to go through every single number, every single index, and it's for every index, there's an element associated with that element, with that index in the array. For a nested array, it's a little bit more tricky because when we go through, so if I look at this RSVP groups, this outer array, you'll notice it has both arrays and also strings, right? And if I wanted to print out, in this case, every single person, every single name in this RSVP groups array, I kind of need to be careful, right? Because if I encounter a name, or sorry, if I encounter a string like Jack, all I'm doing is printing out Jack, right? But if I encounter an element and the type of that element is an array, then I can't just print out the array, so to speak. I need to go into that array and print out every single element inside that array, right? And if you start thinking about what I just said here, if I go into an array and print out every single element in the array, well, I'm treating that inner array almost like how I'm treating my outer array, right? Which is basically I'm creating a for loop, with an index of 0 to the length. I'm going through every single index and trying to see, hey, what are you? If you're a string, I'll print you out, right? And so this for loop can be a little bit hairy, but once you look at it, hopefully it becomes a lot clearer here. I still start with my traditional for loop on the outside, where I start at index 0 and I go to RSVP groups.length. And then I actually go and say, hey, let's just really quickly on line 4 there, make a variable called element, right? And this element is going to be, at every time we run this loop, this element is going to be, this first element, this second element, and then this third element, okay? And here's kind of like where we actually do that thing right where it's like, hey, if it's a string or if it's just a name, we do one thing. If it's an array, we do something else, right? And well, voila, there on line 5, we see our array.isArray function that we talked about yesterday, which basically says, hey, if I feed an element, it'll just give me back a boolean, true or false. Is this an array or not? If it's true, we'll come back to it. But if it's false, what do? Well, if it's not an array, then by default we assume it's a string, right? So we just print out the name here. So line 12 there should look very, very familiar to you because that's exactly how we would do this function if we only had strings, right? Sorry, if everything in here was a string, then line 12 is kind of how we would print out every single name in the array. But in this case, because every element can either be an array or a string, if it's a string, we still do the thing where we just print out. If it's an array, what do? Well, in line 6 through 9, we have another for loop here. And this for loop looks almost identical to the for loop on line 3, right? And why is that similar? Because, well, we're trying to do the same exact thing, right? Which is I'm giving you an array, and then you're just basically going through every single element in the array and printing out for me. For now, at least, we're going to assume that everything inside this inner array is going to be a string, as in we don't have any arrays that are nested three or more levels deep. When we get to the recursion lecture on Sunday, we'll talk a little bit more about how we're able to solve those kind of problems. But for now, we're just going to say, hey, this nesting, so to speak, only goes one level deep. At the very outermost level, everything inside of it is an array or a string. And if it's an array, then everything inside that array is always going to be a string. And so that's why inside this inner for loop here, you'll see that we store name, this temporal name equals element at this index, and we just console log out name. Notice how here on line 3 we use I in the for loop. On line 6 now we have to use J, because if we use I here again, it's going to override the previous version of I, and it just makes it really messy to read the code. So that's why we use a new iterator or a new whatever, right? If this is confusing to you, if I or J you feel like it's too vague, this is just a variable you're creating. So call it whatever you want. Call it outer index and inner index. Call it whatever you want. That makes it easier. At this point, you're creating a variable. You're dictating every element of the for loop or every aspect of the for loop. So this function basically says, hey, let's go through this outer array once again. For every element, we do a check. If the element is not an array, we go to line 12 and we print it out. If it is an array, we go to line 6, we create a for loop, and we actually go through every single element inside that inner array and print out the thing. And so once we go through every single element in the outer array, we should theoretically have printed out every single name in this list. Cool, good. Tom, do you have a question?
No, it wasn't related to this specific. I wanted to ask you if you can write an array not recursively. Or you have to know how nested it is.
Yeah, in situations where you don't know how complex an array is, recursion is probably your best bet. Because otherwise you don't know how many times you have to do it essentially. Cool. And then this is the last thing. So this last thing is a little bit more of like a fun to know. Although you'll be doing some problems with it. We can store arrays inside other arrays, and while a computer will never print it out in this way I'm showing you here, we can obviously draw it out this way. Like if I have an array and every element in and every element is another array with coordinates. Well, this essentially is kind of like a grid, right? Like I'm essentially creating a coordinate plane, right, or a kind of a plane in which every single combination of numbers is going to give you a point, right, or an element in that grid. And indeed, like if I had to look through this, right, this 1, 2, and 3, this is kind of like the y-axis, if you will, right? And then the element number inside this out of like row 1, row 2, and row 3. That's kind of like that's the y-axis. The 1, 2, and 3 are the x-axis, right? And so when I do something like grid 0, or grid index 0, that's saying, hey, go to the first row and go to the first column in that first row. And so this becomes kind of like the topmost left corner of my coordinate, right? And so on and so forth. And so, I haven't done anything differently. This is just kind of another more visual way to think about why we use nested arrays in some cases, is because we want to represent a graph, and nested arrays actually do a really good job of creating kind of like a graph plane for us to start playing around with. If I wanted to say, hey, give me the first row or the second row or the third row, it's remarkably easy, right? I just go to grid and say, your first element is going to be your first row, right? Because it's all one array. Your second element is going to be your second row, and your third element is going to be your third row, and so forth. So getting a row is actually remarkably easy. Getting a column is a lot trickier because.
You mean your first element is going to be your 0th row? No.
Sorry, your 0th element is your first. Yeah, sorry. The element at index 0 is going to be your first row,
Okay.
but your first element is also your first row because your first element is a 0th index.
Okay.
Right. You don't have like a 0th element, if you will. You only have a 0th index.
Oh, okay.
Yeah. But yeah, so like the first thing in your grid is going to be your first row, and so on and so forth. But if I was asking you, hey, can you give me your first column? Well, now that's not so easy anymore because guess what? To get your first column, you need to basically go to every single row and say, give me your first thing, give me your first thing, give me your first thing, and then you kind of join them back together, which is exactly what we're doing on line 13 here, right? On line 13, what we have is, in order to get the first column, we create an outer array, and this array is going to have, in this case, we're looking at a 3x3 grid, so the first column is going to have 3 kind of values, right, or 3 coordinates. The first value in the column is going to be, once again, first element in that first element. So it's going to be row 1, column 1. The second element is going to be row 2, right, index 1, and the first thing there. So it'll be line 9 and the first thing, or index 0. And then the third element is going to be the third element in grid, which is line 10 there, or row 10. And I'm going to look for the 0th index there. And so this is just kind of a janky way for us to go through every single row and ask you, hey, what's your first element? And we store all that in its own array to kind of get this first column. And obviously the way we do that for any other subsequent columns is we still need to go to every single row, but instead of adding it for the 0th element in all 3 cases here, we would just ask for the whatever column number that we're looking for. A bit kind of contrived right now, but if you really think about it, there's not really a better way for us to represent a grid, right? And in fact, this does it very well because these are just glorified XY coordinates.
What about a matrix? Is this your best bet for a matrix too?
Okay, so are you asking in the sense of like how would it, are you asking it from a mathematical computational standpoint, or
Yeah,
is this,
like if I wanted to solve 3 equations, 3 variables, like I guess I could teach this thing how to find a,
yeah, I mean so there's a few ways to like if you're trying to do anything that's like kind of like more specifically math related, there's probably honestly probably better libraries that have been kind of written by other people to do math. But if your goal is to kind of show it in a very more visual, human-friendly way, then this is probably also your best way to do it as well. The reason why I make that distinction is just because when you're talking about like with computers, there's a difference in kind of like computational efficiency versus kind of almost like explanation efficiency. There might be a quicker way to do math here rather than using an array system. But for us, at least, an array system is definitely the best way to visually kind of see a lot of these things. And so we use grids, so like tic-tac-toe or battleship, a nested array is probably the best thing we have using kind of more primitive data types. Any other questions on nested arrays? Cool. That's pretty much it. So that was today's lecture. So we talked about the splice, the join, and the concat methods for arrays, and then we talked about nested arrays. Nested arrays are going to be around probably for the rest of this class, or like rest of this cohort too, because we definitely do come back to it in later sections. So in today's workshop, you'll basically be recreating a lot of the functions we've discussed, and then obviously also doing a little practice with nested arrays. One other workshop that you'll see kind of pop up in your dashboard is something called the Sudoku project. As the name indicates, you're basically building your own kind of Sudoku validator, and so obviously you'll be making a lot of use of the nested arrays. In the month-long version of this cohort, we have a day for you to work on that or kind of go through it. In the week-long, because we're kind of doing this math sprint, we don't dedicate any class time to it. So I've opened up the workshop to you. If you have any free time over the next couple of days, feel free to do it. By and then tomorrow, I'll release the solutions for the workshop too, so you'll be able to check your answers if you want. I'm also happy to answer any questions before after class, in kind of an optional review capacity. But just know that project is intentional. It uses nothing that you haven't learned already by this point, so it is very doable from a pure knowledge standpoint, and it's completely optional practice, and it's just a lack of time that really keeps us from dedicating more time to it in the actual class itself.
Does it take a long time?
It might take a while. I don't know if it's 5-6 hours, but it'll be probably at least 30 minutes to an hour, minimum, to work on this. So, yeah. And then,
My name's Brandon.
Brandon? Oh, sorry, and what was your name?
Hubert.
Jupiter? Hubert, sorry.
H-U-B-E-R-T.
Hubert and then Brandon. Okay.
Yeah. Just wondering, so when we finish the cohort, this cohort,
Yep.
Do the courses and solutions and problems close online at all, or we have access to them?
No. As far as I'm aware, you have indefinite access to them. And I mean, I say indefinite, I haven't tested it out yet, but I don't think we ever take it away from you. So.
Okay.
Yeah.
Cool.
Oh yeah, and yeah, if you don't have time to work on it this week, fully understandable. Once next week and you have more free time, feel free to come back and work on the optional problems that you can get to, during this particular week. So.
Wait, are you saying we can come back?
No, as in the panes will be open, and so you can always come back and look at the solution videos and all the materials. Yeah, the materials are open to you indefinitely from here on out. Yeah. Cool. Any other questions? Awesome. Okay, so let's do a head count. 3, 6, 9, 12. Okay, so we know 11 because I think those two are both fellows at the end. You're both fellows, right? Great. So 11. Okay, so someone's missing. So we have one group of 3.